Today's session will be an interesting session. It is on NLP and text mining. You may get a chance to include NLP project also in your CV, because no matter what subject or no matter what domain you are working on, it doesn't matter, because NLP is across various domains. It's not like only in the credit risk you will use the NLP problems, or only in the marketing you will use NLP, or only in e-commerce you will use NLP. It's not like that. No matter where you are working on, what does NLP mean? Natural language processing. Natural language processing, or the text data. Okay. So when you are handling the text data can be in any industry. So no matter which industry you keep on, you can always put a project on text processing, text mining, or natural language processing, or sentiment analysis, something like that. You can always keep a project on it. But text data handling is not same as numerical data handling. All the techniques that we discussed until now, regression, logistic regression, decision trees, random forest, boosting, all the techniques that we used until now, all the machine learning algorithms that we used until now, none of them will be able to work on non-numerical data. Non-numerical or the text data, they don't work. They are all meant for numbers, numerical system. Numbers data only they'll work. Non-numerical data, these algorithms don't work. What is the reason? Let me give you an example. Here is the review for a particular product. This vacuum cleaner sucks. So the vacuum cleaner is the product and this is the review. Is this a positive review or is it a negative review?
Negative.
Why do we buy the vacuum cleaner for? For cleaning purpose only. And it is doing its job. Think about it. This vacuum cleaner sucks very well. I'm pretty happy with it. It consumes very less power. I'm very satisfied with this product. Is this a positive review or negative review?
A positive review.
It's a positive review, isn't it? In some context, it's a positive sentence. Or if it says this vacuum cleaner sucks, has, star, dollar, and all that, then we know that it's a negative review, isn't it? The same sentence without even changing a single full stop or comma or not even a space. The same thing can be sometimes positive. The same sentence can be sometimes in the negative context. Do you agree? The same thing without changing anything. It can be sometimes called as positive. It can be sometimes in some other context, it can be called as negative. That's the problem with text data. Text data is ambiguous. It is language. It is meant for expressing emotions. It is meant for communication. When people were creating text, they never thought that it will be used in machine learning. It will be used in data analysis later on. People never thought that. That's why text data is little ambiguous. Whereas numerical system is unambiguous. If I say -5, I have to give you $5, +5, you have to give me $5. They don't change their meaning. Even if I keep -5 in the context of -2, -3, +3, or +20, whatever is in the surrounding, -5 meaning is always -5. +5 meaning is always +5. There is no ambiguity in the numerical data. Text data is there is a lot of ambiguity. Ambiguity in the sense, lot of things are not clear. Based on the context, the meaning may change. Do you agree? I never had such pizza before. Not sure about future either. Is this a positive review or a negative review? Sometimes it can be very sarcastic negative also. This is a movie review that I got directly from a website. No action, no drama, no comedy, no romance, just pure horror. No action, no drama, no comedy, no, just pure horror. It sounds positive review, but the movie name is Salman Khan's movie Radhe or something. Now, if you see that in that context, is it a positive review?
No.
It's
It's
a
a
very
negative.
much negative review, isn't it? Very sarcastic. That's the problem with text data. Text data is ambiguous. You have to handle it slightly differently. So what is text mining? Making sense out of text data. Data mining on the text input. Your input is text data. Exploratory data analysis on the text data. It is also known as natural language processing, NLP, or sometimes this field is known as text mining. Can you give me examples of text data sources? Everybody think of from where, like some of the sources of text data.
Social
Giving
media.
reviews.
Reviews, that is a good source. You have product reviews or service reviews or something like that. Yeah.
Social media.
Social media comments, you mean to say? Social
Yes.
media comments, or sometimes social media posts, right? Yeah.
Surveys.
In the survey, some verbatim will be given, right? Survey final comments, like you will have all the questions, finally give the, this is a very important one, isn't it? In a survey, write down your final comments or something. Yeah.
Bot.
A chatbot, isn't it? When people
Yes.
interact with the chatbot, yeah, those comments. Twitter, isn't it? Tweets, isn't it? Twitter, Facebook comments, like that. What else? Sometimes customer emails, isn't it? We may have to analyze emails also sometimes. Do you agree? Like what the email is belonging to? Is it a customer related or legal related or something like that? Email classification also we may do. Some blogs, some blog articles,
Messages.
messages, SMSs, isn't it? Messages. Yeah. If we are somehow getting the customer data, messages, news articles sometimes. Okay. Sometimes you take the physical documents, you scan them. Some tools are there, right? They extract the text from the scanner. Have you ever seen such thing? Like you have a physical document, old
Yes.
document, and then you extract. Sometimes when you are doing verification, automatically when you put Aadhaar card, automatically the text will be gathered from there, something like that. The text from the scanned documents, like that. This is the proper text. Let us suppose if you have a feature called gender, which says gender male and female. Is this the real text variable? Is it, does it come under NLP? Do we need to do NLP on it? Let's say you have something called region, which takes values east, west, north, south. Is it text data?
No.
It looks like text data, but it is not true text data, isn't it? Here, though it is text data, it is mostly numerical data only, numbers only. Do you agree? How do we handle it? Convert it to 0, 1. That is label encoding. Either that we do it, or what do we do when we have this data?
One hot.
One hot encoding, isn't it? Do you agree? All of you? Though it is text data, we convert it to numbers and work with numerical methods only. Do you agree? Though it is text data, this is not pure text data. This is what categorical variables. So your categorical variables are not text data. What I'm talking about is proper pure text data where emotions, where real text verbatim is given. Have you understood the difference between categorical data, which is also non-numerical, but the real text data, which is non-numerical? So non-numerical data has two types. One is categorical, the other one is proper text. What are we discussing right now? This one comes under NLP. Is this point clear, everyone? Though this is text data, lot of time we do it either label encoding or one hot encoding. Let's say you have a variable called income. It takes low, medium, high. Tell me, is this text data? Because there are text. Is this a text data or it is numerical only? That means like it can be converted to numbers. If you have this data, are you going to apply NLP or are you going to apply some other technique? Think about it.
Numerical.
Numerical. So how do you convert this? Income, low, medium, high. How do you convert this into numbers? Are you going to do label encoding like 1, 2, 3, or are you going to do one hot encoding?
One hot.
Like
It should
income
be
1,
label
income
encoding.
2, or income 3?
Label.
Think about it, everyone.
It should
Is,
be label encoding only.
is label encoding fine here?
Yes.
Yeah. Why it is fine?
Yes.
Is 1 less than 2? 2 is less than 3. Is it true? Low is less than medium, medium is less than high. Is that correct?
Yes.
Yeah, label encoding, does it make sense?
Yes.
Will you be able to think like when to apply label encoding, when to apply one hot encoding? Yeah. Let's say customer type, blue, red card, or green card. Are you going to do label encoding or one hot encoding?
Why not?
Here, can I put 1, 2, 3? Is it a good idea?
No.
Why?
It
It is.
depends if it is a
It is
silver
nowhere
there is
related to it. Means nowhere we
Isn't
can
it? There is
compare.
no order. So this is not ordinal. This can be ordered, isn't it? Yeah. If you can order the variable, then you can do label encoding. If you cannot order the variable, then one hot encoding is required, isn't it? Based on the situation, will you be able to find out which one is the right method, label encoding or one hot encoding? Will you be able to do that in future? Yeah. But
Yes.
we are not talking about these categorical variables here. We are talking about the text data. Okay, text data sources are customer emails, customer feedback, customer reviews, blog articles, or tweets, or news articles. Overall, any free text data is that need to be analyzed using NLP technique. What we need to do is first we need to prepare the data. What happens is numerical data is very well structured. Until now, any data set that we worked is very well structured, isn't it? You have variable 1, customer income, variable 2, customer expenses, variable 3, customer credit score, variable 4, monthly utilization, variable 5, customer age. Everything is well arranged. If I take one column, only age will be there in that column, isn't it? You don't put anything else. Everything is for first row, everything related to one customer will be given in the first row. Everything is arranged very well in the form of rows and columns for numerical data. Whereas for text data, what do you have? Document 1, customer 1 review, let's say customer 1 review, customer 2 review, customer 3 review, customer 4 review, customer 5 review. Like the way for one customer, you have exactly 20 features. Is it possible that every customer will be exactly using 50 words, 50 words, 50 words? Is it what is going to happen? Do you think all the reviews will be exactly of the same length? Everybody will be starting with the only. Will there be any structure like that?
No, sir.
It is totally unstructured. Do you agree with that point? Text data is totally unstructured data. While you are doing text data analysis, what we need to do is there is the important point coming up. What we need to do is give some structure. Somehow we have to convert text data into structured numerical data. So there are two steps in NLP always. Any NLP model in this world. First, take the text data, take the text documents. What you need to do is give structure to this unstructured text data. That is step one. Once you have given the structure, once you have converted it into numbers, this is numerical data. Once you have converted this text data into numbers, then you will be able to do numerical data analysis or machine learning or anything like that. Okay. Converting non-numerical data to numbers is step one, which is going to be a tricky step. Do you agree? Converting text data into numbers is not an easy task. That requires good technique. We are going to discuss the technique. And then once you have the numbers, then doing the numerical analysis can be little easy. So the first step is giving structure to unstructured text data. Okay, that is the first step. So let us see some NLP terminology. Usually we have worked with data set, my training data, or data set, or overall data set while we are working with numbers, isn't it? And we deal with rows, we deal with columns. Whereas in text data, instead of data set, the full data that you have, it is known as corpus. Okay. The full data that you have is known as corpus. You will not hear anything like here you go, this is my overall data. You will not hear something like that. In numerical data, you have data set. Whereas in the text data, in NLP terminology, you have something called corpus. Corpus means full data, full text data. Okay. Here we have one row for one customer. In corpus, one item is known as one document. Don't think the literal meaning of document. A document doesn't necessarily mean a Word document or a notepad document. No. A document means one row or one element or one record or one observation. One observation is known as one document. Document doesn't necessarily mean it is a literal document. For example, you are analyzing 5,000 reviews. Tell me what is corpus in this context and what is document in this context. You're analyzing
Collection of
5,000 reviews.
collection of all reviews called as corpus.
So all the 5,000 reviews is corpus. Then what is one document? One
With a single
document is
review.
one
Single
document is one review. Let us suppose you are analyzing 5,000 tweets. What is corpus? I gave you a document. I gave you one Word file. In that, I gave you 5,000 tweets, or I gave you CSV file with 5,000 tweets. Tell me what is corpus? What is a document?
The whole tweets is a corpus.
All the 5,000 tweets is corpus. And what is a document?
One tweet.
One tweet is one document. Are we going to say this is a one CSV file? That is why I have only one document. How many documents we have in this context?
5,000.
5,000 documents are there. Are you clear on this? What is a document? All of you? Document doesn't necessarily mean one document. Document means one row, one entity, one observation. Is it true that sometimes one line itself, one line is one document? Do you agree? Sometimes 5 lines is one document. Sometimes one complete one paragraph or 2 paragraphs is one document. Do you agree? A document is not literally the doc file or document. Document means one row or one entity. Okay. So we are going to use two packages for handling text data. One is NLTK, the other one is sciPy. Both of them are good. We are going to use both the packages for handling text data. Installation is pretty straightforward. We install NLTK, we install sciPy. But there is one extra point here. While you are installing NLTK, it will be installed partially. Okay. What you need to do is you need to run this command nltk.download all. If you do this, full version of NLTK will be installed. You may want to take a side note on it, like to install the full version, which we require for handling the text data. You have to say nltk.download all, then the full version will be installed. What we do is to understand all the concepts here, we will take a case study and we will try to see what are these text pre-processing techniques that we need to know. How do we convert non-numerical text data into numerical tabular format so that we can do the analysis, converting non-numerical data into numbers. How do we do it? Okay. So there are some techniques that we are going to discuss, because the non-numerical text data, the documents that you have, they have some issues. What are the issues? This is not meant for analysis. This was meant for expressing the feelings. Text data is meant for communication. That is why there is some slack that we do not require while we are analyzing the data. For example, there are something called stop words. There are some common words that appear in every document. A, and, the, this, is, it, was, that, are, you, we. Let's say if you have a positive document, let's say if you have a positive review and you have a negative review. Tell me, these words, these stop words that appear, okay, do they appear in positive review or do they appear in negative review? Words like this, a, and, this, was, is, are, you, we. Tell me.
Both.
Both. It will
It
come.
doesn't matter. Do you agree? Whether it
Both.
is a positive document, whether it is a negative document, it doesn't matter. That means whether this word appears or not appears, it doesn't decide whether it is positive or negative. So we can safely remove these kind of words. Why we need to remove? If you do not remove the machine learning model later on, you know what it will think? The same word is here. The same word is here. There is not much of difference between them. The machine learning model will get confused. It will give us lesser accuracy. Why it will give lesser accuracy? Because it has seen the same thing here. The patterns are same here and here. That is why we need to identify these top words and remove them. Keep only the rest of the gist so that we can build a stronger model. Otherwise, ML model will get confused. In the language, you have present tense, past tense, future tense, plural, singular. Let's say if you have buy, bought, buying. Tell me, to a machine learning model, since there are three spellings, shall I treat them as three different words, or it's all meaning the same? It's just the same root word. What do you think? What should I tell a machine learning model? Machine learning model is going to treat them as three different spellings, three different words. Are they really meant to be three different words?
No.
It's the same meaning, isn't it? From the analysis point of view, all of them are same for me. Do you agree? Maybe from the language point of view, they may not be same. But from the machine learning model point of view, I should tell the machine learning model they are all the same. Do you agree? I have to convert all of them into the root form. Sometimes you have 29 December 2021. Numbers are there. These numbers are not useful for analysis. You can ignore them. Especially if you take social media data, you will have a lot of other issues. What are the issues? Sometimes you will have HTML links inside the text. Do you know that? When you are extracting the text from social media, sometimes you will have image links or HTML links. Are they useful for analysis? If it is HTTPS or something, are they useful for, let's say, whether it is positive review or negative review? Does that link decide? No. Email addresses can be removed. Image file links can be removed. Some website tags can be removed. Like that, there are some unnecessary information that need to be removed. Okay, especially if the data is from social media, especially something like Twitter or something. This is one of the most problematic data, the Twitter data or Facebook or any social media data. That is one of the most problematic data. What we need to do is we need to identify all these issues and remove those issues, clean the data, then convert it into numbers. Sometimes spelling mistakes will be there. Do you agree? Spelling mistakes need to be corrected, uppercase, lowercase, all these pre-processing need to be done. What we will do is we will take one of the difficulty data sets, then try to clean it up. So the data set that we are considering here is Twitter data. There are nearly 27 tweets, 27,000 tweets are there. We have tweet ID, raw tweet, and one extra column called sentiment label. We can ignore this column for now. Focus on the real text data, which is raw tweet. Okay. Raw tweet is given here. These are some 10 sample tweets. We are going to handle these raw tweets and we are going to pre-process this data, analyze this data. Let's go to the code file, import this data set. Let's go to the code file. NLP data pre-processing is the session name. This is the code file link. I have pasted it in the chat window. First, install the package, import the data set. Once you have imported the data, once the sample 10 tweets get printed, send me a confirmation message. Then we will get started with the discussion on this data handling. Once you are done with the importing, send me a message. So I can see the tabular output and sample tweets are printed. Once we have this output, let's wait for others to complete this. Any issues anybody else facing while importing it? Two people could do it. So for others to complete this. Is it taking a lot of time? Shall I wait for 1 more minute? Are we good to proceed? All right. Everyone has imported it. So what we do is we convert everything into lowercase because whether the text is in uppercase or lowercase, it doesn't really matter. So here is the code for converting everything into lowercase. There is something called lambda function, apply and lambda function. Are you done with apply and lambda function? Do you recollect from the initial Python? So how do we apply this lambda function? Let's say raw tweet is the tweet. For every row, I want to convert everything into lowercase. This is what I'm doing. I'll go to Twitter data. Twitter underscore data is my data set. Take the raw tweet, then dot apply lambda lambda text. Until here it is set text. Go to this data set, take this column, then dot apply lambda x, and whatever function I mention here, that will be applied on this column on every row. So the function that I'm applying here is right now lower x dot lower. What it will do? It will take x, which is like every x here. X here mentions every row. Okay, it means every row, every tweet. Convert it into lowercase. If there are any rows that are having only numbers, let's say 15, 2019, something like that. Somebody did not tweet a text, he tweeted a number. Then there is no lowercase to the number. That is why first convert every tweet into string, strx. Converting everything into string, then converting into lower cases. What this will do at the end of the day, it will convert every tweet into the lower case. We are storing it in a new column called tweet underscore lowercase. So how does that code look like? Check this once again. Twitter data raw tweet dot apply lambda x. Your data set name, your column name, dot apply lambda x, and then convert it into convert every x into string. They're already strings. But what if there are some places, because we haven't seen all those 27,000 tweets. There are some places where totally numbers are there. Convert that into a string, then apply the lowercase. Once you do that, how does it look like? You have the raw tweet, which has upper cases, convert everything into lowercase, convert everything into lowercase. Nothing much. That's a simple thing. That is the first thing. The second thing is we have to do tokenizing. Later on, when we are doing data pre-processing, we may have to take each word, one word at a time. And each word is known as word token. Converting one tweet, let's say if this is a text. Converting into token means this is token 1, token 2, token 3, word token 4, word token 5, word token 6, 7, 8, 9, 10. There are 10 word tokens. Converting one tweet, one string into 10 words or tokens. Why we do tokenizing? What is the need? Later on for data pre-processing, we may need these tokens in some cases. That is why. Again, what is the syntax? Go to Twitter data, take lowercase tweets, apply lambda x. Word tokenize is the function which is taking x each tweet as input, converting it into string, and then once we apply word token, how does it look like? Here is the code once again. Word tokens, new word tokens equal to take the lowercase tweets, apply lambda x, word tokenize. And here is the output. How does it look like? This is the actual tweet. Now it looks like, look at this, tokens. Token means what is a token? One word is one word token. Token, token. And this is little smart also. Look at this. Question mark is taken as one token. Exclamatory is taken as one token. So it is simply not splitting it based on space. It is identifying special characters also and then dividing them into tokens. Look at this. Exclamatory mark itself is one token. Remaining 1, 2, 3, 4, 5 tokens are there. Okay. Converting it into tokens. Why do we need to do the tokenizing? Later on, these tokens will be used. Okay. So this is one example, and these are the tokens. The next thing is, especially when you are working with social media data, there will be a lot of short forms. Ain't means I'm not. Could have, could have, couldn't have, could not. Don't, do not. Like that. Some people write don't. Some people write do not. Somehow I have to tell my machine learning model that this also means do not only. This also means do not only. Don't consider this as a slightly different spelling. What we need to do is we have to expand the short forms. Obviously, there are so many short forms and we need to convert all of them into expanded form. So here we are creating a dictionary. So I have gathered from internet what are all the most widely used short forms in the internet and then what is their expanded form. Okay. And here is the syntax for converting short forms to expanded forms. Okay. What does it do? I'm writing a function, expanded form. What does it do? It will take each token. It will take each token from the tweet. Okay. Then look at this dictionary. Go through this dictionary. If that token is in the short form, it will be given in the expanded form. So it will check if it is in the keys. That means in this dictionary, these are all keys. The short forms are keys. If it is in the keys, corresponding value will be given. Okay, return the value. Because in a dictionary, if you give the key, the value will be given to as output. The value is what? The long form. Otherwise, return it itself. Let's say it's is there, converted to it is. Remaining are left as it is. Otherwise, if it is not in that dictionary, it will be given as it is. If it is there in the dictionary, give the long form. How does it look like? What are some of the examples? Let us see. If you see here, any of the examples can you see? Don't is now converted to do not. Like, let us see the code. Twitter data, tweet lowercase, apply, lambda x. Now this is known as list comprehension. What is list comprehension? Output, condition 1, condition 2, condition 3 like that. Output is expanded form T. Okay, expanded form is this function. Output is expanded form T for T in this whole tweet. Okay, so split the tweet, take each word, supply each word to this dictionary, and the expanded form will be given to you in the output. How does it look like? Once again, write this function which gives you the expanded form, and then this is an example from original tweet to the expanded form. Name first specify in the dictionary, then write it. It's is converted to it is. If you repeat the same thing for the whole tweet, what you will see is for the whole data set, don't is converted to do not. Is there any other example? If you re-execute it, a different sample of 10 records will be printed. Can, this is cannot. Like, this is just an example dictionary which has so many words already. But if you feel in your data set there is a new form, let's say in your data set you found something called lol, then what will you be converting it into? Something like laugh or something. But sometimes that itself is taken as a word, then you can ignore it. But this mostly for most of the social media data it covers. The remaining things you may want to add and expand this whole dictionary on your own. Okay, as of now, this will do for most of the social media data. Here is another example of another templates. Complete it until here. Once you are done until here, expanded forms, send me a message.
So this function which you showed now for expanding the short form, that is a defined function we have created it, right?
Yes, we have, like, basically we have created the dictionary. Okay, and then we have defined it. That means this is
So
the
the
function.
spacey or NLTK don't give us any function
they,
for
they
this.
have they have the function, but they are not as wide as these. Okay, there are some
Okay.
function, but expand into short form to long form, that function is not there in spacing and all.
Okay.
Once you are done until here, expanding the short form, send me a confirmation message, then we'll proceed.
Excuse me, sir. So I could see here few special characteristics like stars, and it was continuous, right? So it was taking as a separate token, including all 4 stars. And
Correct.
so, can we do any other method for
Yes,
the remove method?
we have to remove them. Not only stars, even
I'm telling, for example,
these
we have
isn't it?
HTTP.
HTTP addresses. So those also need to be removed. It is actually coming up. That is also Slack data that need to be removed.
Okay.
We have methods to remove it. In fact, one of the pre-processing, we have only for 2 steps we applied. One is converting to lowercase, then we expanding the short one. Like that, the next thing, like that, 6 or 7 steps are there. One by one, one by one. One of the steps is removing these special characters.
Okay, sir.
Sometimes numbers will be there. Those numbers need to be removed. The next step of pre-processing is stop words removal. First of all, what are stop words? Stop words are those words that will appear in every document, whether it is positive, whether it is negative, whether it is legal, whether it is customer related, politics related, no matter what document you have, these words will be there everywhere. A and D. This is, was, for, are. Basically, they themselves do not have any meaning, but they still present because for the sake of completeness, because English is a language. Yeah. Tell me any other examples of stop words. Any other examples of stop words? Everybody think of an example of stop word. Some word that is there in almost every document, but it doesn't have its own meaning. So write down one or two stop words, everyone, apart from these.
Off.
Off. That is a stop word. Correct. So is a stop word.
So
That's right.
to.
To is a stop word. Think about it, everyone. Think about a stop word. They, is it a stop word? Them, these, isn't it? For is a stop word. Correct. What else? As, is it a stop word? At, is it a stop word? From, is it a stop word? Be, isn't it? All these are stop words. Basically, they themselves. And is it a stop word? There are so many such stop words. English is a huge language. There is a list of stop words that NLTK provides. NLTK has given 179 stop words. There is a list of stop words that sciPy has provided. 226 stop words. It has listed down. Is, has, do, does, okay, doesn't, can, by, be, at, both, between, below, off, on, once, only, or, other, ours, ourselves, now, most. These are all stop words. What we need to do is we need to identify all these stop words and remove them from the text. Tell me, let us suppose there is one positive document. Here also there is. In the negative document also there is. Is it okay to remove them? If I remove them, am I going to change the meaning of positive? Am I going to change the meaning of negative?
No, sir.
The gist will be kept. In fact, we have to remove them. If you do not remove, if the same words are found here and here, the machine learning model will get confused. We think that the same patterns are found here and here. We have to remove these stop words. We have to identify and remove these stop words. It's not true that you have to remove all these 326 stop words. If you feel that I want to keep the negations, let's say I want to consider this as not a stop word. Doesn't, I want to keep it. Not, I want to keep it. That means out of 326, I would like to say 300 only stop words. Remaining 26, I want to keep them. That also is also possible. Otherwise, in general, you can remove these 300 stop words also. So how do we remove these stop words? Look at this code. Take all the word tokens, apply lambda x. Then what do? If take the word, if or word in this whole tweet, if it is in sciPy, stop words. If it is not in sciPy, stop words, give T as output. That means if it is not a stop word, give T as output. If T is in sciPy, stop words, then you ignore it. Basically, you are getting only that output where if it is not a stop words. I will be removed. How will be removed? Pride is kept there. And then I am now. These are all stop words that got removed. Another examples are like off will be removed, to will be removed, so is removed. This is one of the most important steps because English language is filled with stop words. Do you agree? Stop words, the meaning itself is that they are present everywhere. If you do not remove stop words, the machine learning model will find the same text, and later on the machine learning model will get confused while doing the classification. We can do a little bit of customization. Let's say 326 stop words are there. I want to take only 300, that is fine. Or if you want to add some more stop words based on the context, you can add them. Let's say if I'm working with iPhone data, apart from all these stop words, let's say iPhone reviews is what you're working on. Apart from all these stop words, few more stop words need to be added. Do you agree? If you are working with iPhone review data, which is having around, let's say, 30,000 tweets, tell me what are the stop words in this context. iPhone reviews, 30,000 iPhone reviews are there. What is the stop word in this context? Apple will be a stop word. Do you agree? In the real world context, Apple may not be stop word, but here it will be a stop word. Do you agree?
Yes, sir.
Everybody will be writing Apple, Apple. iPhone will be stop word. Phone will be stop word. Doesn't matter, isn't it? Because everybody, all the 30,000 reviews are talking about the phone, iPhone, Apple, Mac, only these things only. Do you agree? iOS. These will be the stop words. So what we can do is, let's say if you're working with Twitter data, maybe some retweet or something like that. So here, take the spaces stop words, dot update, and give the words based on the context. These are manual. We are giving them. We are manually giving these words. I am saying would, RT. RT is what? In Twitter data, what does RT mean? You will tend to find this several places. Retweet. Earlier used to come as retweet, RT. Like, ha, lol, need, do, these kind of things are, I am adding them as stop words, and you can remove those as well. Okay. So stop words, those are the words that appear everywhere. It's NLTK stop words. This is the list of stop words given by NLTK. This is the list of stop words given by Spacey. They have gone through lot of documents in this world, thousands and thousands, millions and millions of web pages they have browsed through, millions and millions of news articles they have browsed through, and they have listed these as the stop words, 326 stop words. And here is how you remove the stop words. And it is not a rule. All of you, please acknowledge this point. Is it true that always you have to remove all these 326 words in every context? Is that true?
Mm.
We don't need to remove all of them. If you feel that there are some words that are important for me, we can keep them. Otherwise, in general, you can remove all of it. But it's not a rule, okay, that you have to remove always all these 326 you must remove. There is no rule. 300 or few words if you want to keep. If you want to consider few words as non-stop words, especially negations, if you want to keep them as non-stop words, that is perfectly fine. We can keep them and remove the rest of the words. So here is the data, how it looks like after removal of the stop words. And we can add extra custom stop words depending on the data. Depending on the data, I have added 6 more stop words. 331 is the stop words number now. And these are the words after removal. There was a question about special characters. Sometimes we have some special character like star, exclamation, question mark, hyphen. They are not useful, isn't it, from the analysis point of view? That was the question. The question was, these characters are not useful. Why can't we identify and remove them? Sometimes you have currency symbols, dollar, pound, rupees. They are also not useful. Punctuation, not useful. Numbers, something like 20 November 2021, time 12:53 a.m. Now this thing is not important. You can remove them. This doesn't mean anything. It says positive review or negative review. It has nothing to do. Punctuation, extra exclamation, hyphen, these things can be removed. Sometimes you have HTTP addresses, HTTP, some FB, Facebook.com, HTTP, Twitter.com, something like that. Sometimes email addresses, okay, they can be identified and removed. Especially when you are working with Twitter data, you have something called tweet peak. This tweet peak is what whenever somebody is tweeting with a picture, instead of picture, tweetpic.com, and then some picture address will come, and then the tweet will come. Is this tweet peak really useful? Not useful. So what we need to do is, using regular expressions, we have to identify all these places, because in the tweet or in a review, numbers can be found anywhere. Is it true that numbers will be always in the beginning only first four are numbers, or only last four are numbers? Is it like that? Or the numbers can be present anywhere, or the
Mm.
symbols can be present anywhere? They can be present anywhere in the document. Do you agree with me, all of you? The numbers or the symbols or the links, they can be anywhere in the document. We have to identify them. We have to remove them. How do you identify? Using regular expressions. So regular expression dot substitute, mention the pattern here, replace them with space. That means you are saying remove them, and the string is tweet. In the tweet, give the pattern. So regular expression pattern need to be given. What is a pattern? That means if you want to identify the numbers, this is the regular expression pattern. If you want to identify the image file, this is how you identify. This is known as regular expression. This is a syntax or a code in itself. Everything has a meaning, like this cap has some meaning, this plus has some meaning, hyphen has some meaning, this bracket has some meaning. Okay. If you already know regular expressions, well and good. Otherwise, if you are not aware of regular expression, if you go to the regular expression website, then you will find some of these links, or you will find some of these already pre-written codes. We can use those. By the way, what does plus mean? Does anyone know? In a regular expression, what does plus mean? Plus means like addition, is it? Like including this, or W means I think word or character or something like that. And then cap means starting with or something like that. Okay. So basically, this is a code in itself. If you are aware of regular expression, well and good. Otherwise, go to the website. If you want to identify digits, then these are the regular expressions. If you want to identify email addresses, use this regular expression. So how does this work? Look at this. I'm writing a function called clean with regular expression. It takes our tweet as input. It will check and remove URLs. That means this regular expression will check for an URL. It will identify the URL. Replace it with, this is the pattern for identifying URLs, and replacing it with space. That means removing the URL in the tweet. This is the tweet. Take the tweet, remove punctuation. Few punctuation marks will be removed. Extra punctuation need to be removed, and then remove the digits. So at the end of it, the tweet that we are passing on will be cleaned with URLs, punctuation, and digits will be taken away. Look at this, the examples will be, commas will be taken away, and then 3 will be taken away. Especially this one, you see this? Tweet peak. This tweet peak will be totally taken away. This ampersand will be taken away. This is how, using the regular expressions, you will be cleaning the data. I think this was the question, right? How do we, is there a method to remove that unnecessary text or the punctuation? This answers the question.
Yes, sir.
Yeah. So,
Excuse me, sir.
yeah.
So here, like you removed 3 from the third.
Right.
So after that, RD doesn't sense anything.
Right.
I think.
What we can do is we can add this into the stoppers RD, or we can also identify this RD or IS or 80. So basically 100% perfect we will not be able to do, but we may have to write the code for these as well. Right. True. It doesn't make any sense. This RD.
Okay.
Yeah. But here itself, like we are doing the maximum effort to remove the slack. And after that also there will be these kind of issues that will be still left over.
Okay, sir.
So this is removing the unnecessary expressions or unnecessary links from the text data using the regular expression. If you already have good idea on regular expressions, it is well and good. Otherwise, you can use this function that we have written that will remove URL addresses, that will remove punctuation and the numbers from the data and keep the rest of the data. So you will see that the exclamatory mark is gone. Okay, the regular expression. If I re-execute this code, a different sample of 10 records will be printed. Let me re-execute. Let me see whether any hyperlink, okay, that was there in the original data has been now removed. Hyperlink has been removed. HTTP. The next step is spelling correction. It is true.
We have imported here like import RE.
Right.
That
Regular expressions package is there. Okay. The package name
okay.
is RE. Okay.
Okay, sir. Got it.
So to use these regular expressions, like we have to use that. Basically, the symbols that you see here, it is known as regular expressions. Basically, one regular expression, knowingly, unknowingly, we always use. Okay. Let us suppose if you say import star. What does star mean? Import star. Have you used this regular expression? Anybody? Star.
And
Yeah.
everything, whatever is
All,
there.
isn't it? You did not say import everything, or you did not say import all or anything. We say star. What does star mean? Star is a regular expression, isn't it? Star
Yes.
means all, isn't it? Import all. This is one regular expression that all of us use, but there are other symbols as well. Those are known as that regular expression. So basically, it's a, what do you call it? It's a science in itself, especially people who are working on development, let's say C++, Java, when you are learning. Some of you might have learned regular expression also somewhere. Has anyone learned them previously, separately? When you're learning certain programming languages, regular expressions are also taught, especially the low level languages like C++ or Java. When they are teaching, they will teach regular expressions also.
So then we can directly use that library like import RE
Right.
without using function, creating any function.
RE will help you to work with regular expression. But what we are doing is we are identifying, using this regular expression, we are identifying URLs. Okay. So to
Okay, sir.
identify a URL, you have to write a regular expression, right?
Yes,
And
yes.
to write that regular expression, we are using RE package. Okay.
Okay, sir.
What we are doing, we are removing it. Maybe in the place of URL, later on, I don't want to remove it. I just want to count number of times 9 occurs. Okay, let us suppose you want to count how many times 9 has occurred inside a document. For that, you can write a regular expression. Okay. For that, you have to use RE package, but it doesn't tell you, it will not give you a function how many times 9 occurs. For that, we need to write our own function, right? Have you
Yes.
understood why we have
Yes.
written a function here? It makes sense now.
Yes, sir. Yes.
Yeah. This function is written to use regular expression to clean our tweets. That's the thing.
Yes, sir. Got it.
The next one is spell correction. It is true that, let's say, this is one of the sample tweet. What and great. Instead of great, grat was written. Amazing. Instead of amazing, amazing was written. Excited is fine. Learn data science. That is wrong. It is true that especially in social media, you will have informal text, isn't it? If it is formal, then people will be taking some care. You do not write an email in a hurry, isn't it? Even when you write it, you tend to read it twice or thrice. Official documents will be having lesser spelling mistakes, but informal text, especially on social media data, Twitter data, you may see a lot of spelling mistakes. There is a particular function package called text blob. If you use text blob, if you send the input, spelling will be corrected in the output. Grat will be signs. So depending on the surroundings, text blob has its own package, its own function internally. It will do the spelling correction and give the output. But usually in practice, spelling correction is not done. Spelling correction is not done. The text is taken as it is. Spelling correction is not suggested. Especially when you are working on real data sets, try to avoid this step. When you talk to experts, what they will tell you is this text block, it will give you right spelling. Sometimes in that effort, it may change the meaning also. Sometimes it may change the meaning. Can you tell me what is the wrong thing that the text blob has done here? It has given you right spellings, it's okay. Can you highlight what is the issue with this package? What is wrong that it has done? Something wrong it has done.
Since, yes, I.
Yeah.
Since is taken as science.
If you observe,
So you are not audible. Clearly.
That and what it was.
What is changed to that?
Is there any issue with my voice? Is there any background noise or anything?
Yes, sir. There is some background noise.
Just it.
Yes.
Can you hear me now? Is it clear?
Yes, sir. Now it's clear.
Yes, sir.
Shall we continue like this?
Yes, sir.
Yeah. Thanks for bringing to my notice. Yeah. So what has been changed to that? Tell me, is there any spelling mistake in what? There's nothing. So sometimes in the process of correcting the spelling, in the process of correcting the sentence, what this text blob does is maybe the customer is writing something positive. In that process, it may be converting into negative. Don't you think that's a huge transformation? We don't want such things to happen. It's better to keep a wrong spelling, because at the end of the day, everything you are going to convert into numbers. Maybe instead of mapping great to a number, you will map great to another number. Instead of that, we don't want to correct the spelling and create some errors. So that is why this step in practical scenarios, maybe academically it looks good. On paper, it looks good. But in practical scenarios, when you talk to experts, they will tell you that do not do spelling correction, let it be. Okay. But if you feel if it is an official document where you already see a lot of people use right grammar and right spelling and all that, then you may apply spelling correction. But in reality, spelling correction need to be avoided. But still, I have given you an example. In future, you may have to take that call whether you require spelling correction. Then you can use this piece of code for doing a spell correction using text blob. However, I would suggest that in real time scenarios, spell correction should be avoided. The next one is lemmatization. Lemmatization means converting it into root forms. Creates, created, creating, create. All of them need to be converted to, tell me, all of them need to be converted into one word only, whether it is creating or creates or created, all of them need to be converted to create. Buy, bought, buying.
Buy.
B-U-Y, buy, isn't it? Why we need to do that? Because for a machine learning model, though they are, look at this buy versus bought, very, very different spellings. Okay. But still, I have to tell my machine learning model later on that, you know what? Yes, these two are very, very different spellings, but they still mean the same thing. That is known as converting everything into root form. It is known as lemmatization. So there is a particular function within sciPy. There is a model that we need to load, sciPy model. So what it does is it will take our each of the word and then convert it into root form. For example, I would responded going. Going will be converted to, if you have something like going,
Go.
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 Responded,
Respond.
respond. Would, I would be same. Respond, go. It may not make sense while you are reading, isn't it? Because now we are not interested in reading this. Are you with me? Once you remove all these stop words, once you convert it in root form, it may not be well for reading, but we are not converting them for reading. They may not make any sense while you are reading because grammatically everything we are changing. But finally, for an ML model, it is important. Okay, converting everything into root forms. Here is an example. Living will be converted to live. Forecasts, forecast. Stopped, stop. Gonna, go to. Stuffs. Let me tell you, English is a huge language. Millions and millions of words will be there. It is impossible to convert everything into perfect ones. Still, there may be some gaps. Do you agree? Because such a huge language, different, sometimes ER will be there, sometimes ID will be there, sometimes IT will be there, sometimes RD will be there, sometimes ING will be there, sometimes OUGHT will be there, sometimes IT will be there. So still there may be some gaps. This is also not 100% perfect package. Finished. Ideally, that should be converted to finish, but still it is there. So, but overall 90% of the cases it will do, but still there may be some issues like this because we have to do it perfectly as well as fast. If it takes hours and hours of time for conversion, then it will not be that useful. That's why there may be still some issues, but overall it will do a good job. Okay, converting everything into the root forms, which is known as lemmatization. So what do? We send each and every word, convert it into a lemma. Lemma means what? Root form is lemma. Responded, respond, going, go. Like that, we repeat it for the whole data. Obviously, this step is going to take a lot of time. The reason is every word we need to check. Every word and its root form, every word root form, every word root form. When you keep it for execution, it is going to take a good amount of time. Why? Because we have 27,000 tweets. Even if you take 10 words per tweet, 2 lakh words will be there. Checking 2 lakh words and their combinations and the root word conversion, it is going to consume some time. It is going to take 5 minutes time in this particular exercise. Keep it for execution. It will keep on executing in the background. At the end of this, if there is any further cleaning required, okay, that means somebody has identified, sir, after 3 RD is there. Why can't we remove these as well? Then I will say stopwords.update. I'll put RD as well. Maybe after 2, ND will be there, second. Then I'll add that as a stop word. Maybe I have observed few more things like that. If there is any final cleaning, which is properly manual, isn't it? Totally manual work. Because we are observing few things. The final cleaning, if you have to remove anything, remove them, do the lemmatization, any final cleaning that is required, do that final cleaning. Okay. Once you have taken this raw text documents, pre-processed it, we are now ready to convert it into tabular form. Tabular form or numbers or numerical data. Numerical data. What a lot of people do is directly convert it into numerical data, but I suggest you to get an idea on the data. Get the summary. Get the summary. Tell me, if you have a numerical data, continuous variable, something like income, how do you get the summary for this? If you want to get an idea, you want to do exploratory data analysis, how do you get the summary? What are the measures
Mean
that
and
you look?
median.
You look
SPI.
at the
Mean, median,
mean, median. If you want to get a
average.
better understanding, you want to know outliers and all that, then what do you look at? Percentiles, isn't it? Box plot, like that you will do it. Yes or no? Isn't it? Then you will get a complete idea on this variable. But here, what do we have? Tweets, isn't it? How do you get the idea on this text data? So what you need to create is, you need to create something called word cloud. Okay. The word cloud gives an idea on what is this text. You will get a proper idea by creating the word cloud. Do you know what is a word cloud? A word cloud is something like, let's say the whole text will be taken. The words that are appearing most number of times, they will be appearing with larger text. Let's say if I take the Twitter data from India from last 1 week, everybody is talking about Modi. Modi will be the maximum. Some people are talking about IPL auction. So IPL will be next. Some people are talking about something like budget. Budget will be next. Some people are talking about a movie. Okay. Pushpa will be next. Like that. Okay. Have you ever seen a word cloud? Anybody? Like the words that are appearing most frequently, they will be large text.
Yes.
The words that are appearing. So create a word cloud. How do you create a word cloud? Take the full final cleaned tweet tokens. Take the full final cleaned ones. What are the final cleaned ones? After removal of the stop words, after removal of the numbers, after removal of the HTTP links, after doing the lemmatization, etc. This is the final cleaned one. Then get the final text from there. From there, use this particular function called word cloud. Color map set 1 or set 2, different color maps are there. Like this is just for formatting. Generate word cloud, final text. This is the final text. Remaining are optional. What will be the size of the figure that you get? 15 by 15. And then show the axis, x-axis, y-axis, show them or not show them, like that. But the important line of code is this one. Generate the word cloud. By looking at the word cloud, you will be surprised to know, even without going through 27,000 tweets, you can still tell me the top 10 themes or the top 10 topics of discussion. Topics of discussion automatically, just by going through the word cloud. You will get an idea. You will get an idea. Okay. So let us create that word cloud. So for me, lemmatization is done. And then any further cleaning that requires, that will be done. And then try to import the package for word cloud, get the final text, and create the word cloud. Go ahead, for you also, lemmatization must have been done. Create the word cloud, then tell me what are the top 10 words that you see. Just by looking at the word cloud, you will automatically get to know what are the top 10 words. Only they will appear with larger font. Tell me the words that you see in the word cloud.
Time, love.
So go ahead, put that in the chat window. What are the words? The large text that you see, put them. What do you see? So time, good. Are these the ones that you see? Day, love. I love working today. Work, I have to go to work today. What else you see? I think these are the largest fonts, isn't it? If you go to the next level, what do you see? Next level font mein kaun sa hai? No, new, want, miss, today. That is next level, isn't it? Think. Do you also see the same things that I see? Is this the result that you are also getting? Isn't it? The basic meaning of word cloud is itself that. Means the words that appear most number of times: work, good, day, love, time, think, want. Let's say if I re-execute it, the same thing will be there, but the format will be slightly changed. It will appear in a different format. Okay. The same thing. So what you need to do is, before getting into the conversion into the numerical data, it's a good idea to get an idea on word cloud. Sometimes Some people stop the analysis here itself. Stop the analysis. Sometimes the client will give you huge text corpus and ask you to do some mining and tell me what are the top 10 themes. Do you agree? Sometimes the analysis itself is this. Have you ever thought of any problem statement where the client has given you all the reviews data? They just want to know what are the most talked about points in this list. We will say like these are the most talked about points. Maybe if you're talking about iPhone data, maybe some people are talking about screen. Some people are talking about battery. Then screen will be here, battery or the price, something like that you will see. Okay. The most talked about points will be given here in the word cloud. In fact, you can create fancy word clouds also. Let's say if you have this as the logo, client logo, if you add background image, mask equal to some background image, if you take that image, okay, then the same word cloud will be fit inside this image. It will look somewhat fancy like this. The same output, but it will be inside this one. This is optional. This word cloud generally works. Yeah. Usually all these steps that I told you, for the sake of understanding, we have gone step by step, step by step, step by step. You know, what do we do? In reality, in real life projects, we create one pre-processing function. We simply create one pre-processing function. We include everything inside that only. You take the input text, you take the input data, and then convert it into lowercase, do the short form to expansion form, remove the stop words, clean with regular expressions, which means remove the URLs, remove the numbers, do the lemmatization, convert it into the root form. Finally, if there is any further cleaning that need to be required, etc., etc., do all of that. Do you agree? Does it make sense to create single pre-processing function? Since we are discussing here, we discussed all these steps one by one. You create a single pre-processing function which will take this input and give you the final clean text as output. Maybe in future, you can use this pre-processing function that we have here. It's not, is it system built pre-processing function or is it manually built pre-processing function by us?
Manual.
We have created it, isn't it? We have written our own, so it is manually built pre-processing function. We do not expect it from any other pre-built package. We have used pre-built packages to write this pre-processing function, and then this one line of code, that's it, one line of code, pre-processing, give the Twitter data, clean that raw tweet column. Then your data will be cleaned. Once the data is pre-processed, you are now ready to convert into numbers. The numerical form of the text data is known as DTM. It is known as document term matrix. DTM, document term matrix. In a document term matrix, the documents are the rows. The terms are the columns. Let us suppose you have 3 reviews, 3 documents. Document 1, review 1, review 2, review 3. So inside a document term matrix, you will have 3 rows. Terms means all the unique columns or unique words. Unique words are the terms. And what does this number mean? Here there is nothing, means 0. What does this number mean?
How many times it occurred in that
In
document?
that particular word, in that particular document, how many times it has occurred? This particular word has occurred twice in this document. This particular word has occurred once in this document. Let me tell you why pre-processing is important. Some people, you know what a lot of people do, which we should avoid. All of you, please pay attention. Take the raw data, convert it into document term matrix. All the pre-processing steps that we discussed, removal of the stop words, removal of the HTTP links, converting to lemmatization. They avoid all this. Directly convert into document types. This is going to give you totally wrong results. Let me tell you why. This document term matrix is very sparse. What do you mean by sparse? There will be a lot of zeros in it already. Because one person has used loved, you cannot expect all the people to use the same word while they are writing the review. Do you agree? Another person has used place. You cannot expect this place to be everywhere. That means there will be a lot of zeros. Let's say in document 1, something like create is there. In document 2, creating is there. In document 3, created is there. Imagine you haven't done lemmatization. In the document term matrix, how many columns will be added? How many new columns will be added?
3.
Create, created, creating, isn't it? And what will be the numbers that will be filled? Tell me.
1.
1 0
1
0 0 1 0 0
0
0,
0 1.
or is it 1 1 1? It will be like this, isn't it?
Yes.
Now, though it is single word, are you adding more data or are you adding more zeros here? Tell me honestly. Are you increasing
Zeros.
sparsity or are you increasing information? We are increasing sparsity, isn't it? If you
Yes.
do not do pre-processing, the data will be very, very sparse. Sparse means what? So many zeros will be there. It is almost like saying we are giving some numerical data to machine learning model, but still we are giving it with lots and lots of zeros. Otherwise, if we would have converted everything into create, which is like if we would have done lemmatization, then how many new columns will be added? Create will be one column, 1 1 1. Do you agree?
Yes.
Which one is useful? Is this lemmatization or without lemmatization? Definitely with lemmatization, our data will be, this document term matrix will be rich with data. Less zeros will be there. Agreed?
Yes.
That is the reason why data pre-processing is important, because once you convert into numbers anyway, you can apply ML technique on these numerical data. Like you have rows and columns, numerical data is there, you can apply ML techniques later on. But before getting into ML technique, that pre-processing is important. So there is a function called count vectorizer. What does it do? It will take each and every word. It will count this word, how many times it has appeared in document 1, document 2, document 3, like that in each of the document, how many times it has appeared. Min df equal to 5. That means minimum 5 times a word has to appear. Otherwise, that word will be dropped. Let's say there is a word called, let's say this pizza or thin crust. So somebody has used crust. Crust has been used by, like, there are 27,000 tweets, but crust has appeared thrice only. Then there is no point in keeping such very, very rare words. Ignore them. Minimum 5 times a word appears, then only you keep them. Otherwise, you totally drop those words as well. Then you will have the document term matrix. Usually, document term matrix, usually are they rich with the data or usually they are sparse in general? In general, most of the document term matrix will be sparse only. A lot of zeros only will be there. Does it make sense? Think about it. So somebody has written abandon. Abandon is appearing here. Is it going to appear in all the 27,000 tweets? Is it fair to expect like that? One word to appear in 27,000 tweets? Very rare, isn't it? Somewhere in between 10 or 15 times or maximum 30 times it would have appeared. In the first 5 tweets, it's not there. In the last 5 tweets, it's not there. It's a snapshot that we see here. Lot of zeros will be there. It is a general scenario in a document term matrix. But every word, if it appears here, minimum 5 times it has appeared in the data set. That's why it makes it to the document term matrix. Okay. So the final document term matrix, create the document term matrix. Tell me how many rows are there, how many columns are there in your document term matrix. Number of rows and number of columns. So 27,481 rows, 3474 columns. Can somebody explain me what these two things mean? What does 27,481 mean? What does 3474 mean?
347 are unique number.
Columns. rows.
These are the
481 are the
unique words.
documents.
unique
Documents.
These are the unique words. Perfect. And what are these?
Documents.
These
All
are
of the
the documents.
documents.
Here, one document is what for us? One document is one
Record.
tweet.
One record.
One tweet is a document, and these are the unique words. Is it true that everything is zero only? Since we are seeing zeros here, does it mean everywhere it will be zero only?
No, sir.
Not necessarily. Somewhere in between there will be ones or twice, twos or something, but the snapshot that we see, mostly it will be. This data will be used in the analysis later on. So as I told you, there are two steps in NLP model building. Step one is converting text data into numerical data. Tell me, what is this numerical form called as? Converted these text documents into numbers. What is this called as? This is called as DTM. Try to recollect, what does this mean?
Document
term matrix.
mining.
Document term matrix. DTM means document term matrix. Okay, converting text data into numbers. Step two is building the models on the numerical data. How do you take this data? Because though it is numerical data, the direct models like logistic regression, linear regression, decision trees, random forest, boosting, we cannot apply them directly here. The reason is there are too many zeros. Some special techniques that will understand these kind of sparse data where there are a lot of zeros. There is a technique which is probabilistic model called naive Bayes technique. This will be another machine learning model algorithm that we are going to discuss. Naive Bayes technique works perfectly for this kind of data. We are going to see what is this naive Bayes technique and how is it applied to get the results on this. Okay. This is only the pre-processing and converting into numerical data. So that completes our first part of the discussion in NLP. We will be now discussing naive Bayes technique after a break. But before getting into the break, I would like to take a couple of questions. Any questions, anyone?
Sir, I have one question.
Yeah, please go ahead, Ritik.
Like, yes, sir. If that document contains any emoji, then how it will be treated?
Image, is it?
Emoji, like laughing emoji.
Okay,
or,
emoji means like something like this way, is it? This way.
Yes,
Or this
exactly.
way, like so. Right now in our whole data, we consider these as special characters. Okay, we deleted them. Okay, but there is a particular function for emoji detection. Okay, we can use that and keep it. Let's say for me, I feel that I want to convert it as happy. Okay, wherever this appears, I want to write it as happy. Wherever this appears, I want to write it as sad. Wherever this appears, maybe angry or something. Okay, so we can do that also. But here we did the simple thing. We consider that as special character and remove them. Okay, but special treatment can also be given. We can write a simple function for emoji conversion into text, and then some information can be extracted from there as
well. Okay.
So basically, those are kind of very, very special functions. If we keep on writing them, our model will get better and better, isn't it? As of now, I'm simply ignoring them. Maybe I'll get 85% accuracy. Maybe if you consider them also, maybe you can push that accuracy to 88% or 87% like that, isn't it? Like those are those special functions that will add a little bit more accuracy to the final model. Okay.
Sir, is this NLP would be used for all kind of documents like not only this social media networks type of documents, so we can use for any kind of
Text
requirements,
data.
right?
Text
Yes.
data, correct. So the example that we discussed, something like what are the sources of text data, all the sources of that text data. For example, what are the examples like customer emails, customer feedback, reviews, blog articles, tweets and blog. The reason why I have taken tweets is usually this has so many issues. If you take emails or reviews, when people are writing lengthy sentences with well given text, generally they do not do a lot of grammatical errors, or generally you may not find all these issues that we see. But yes, it can be applied for any type of text data, free form text data. The same techniques that we discussed, the same lemmatization you will apply. Okay, the same regular expressions for identifying the issues, the same stop words, the same thing will be repeated for all types of text data.
Okay.
So suppose for going for the news articles, like the data,
Right.
so there we can see the paragraph of like record paragraphs are there.
Correct.
So for that, I think the approach might be a little bit different. Like we have to the document should be like for after each full stop or question mark like that, we have to separate like for each document kind of thing or words.
Here in news article data, one document is what there in news article. Let's say you are handling around 5,000 news articles. Okay, 5,000 news articles. How many documents will be there in that?
5,000.
5,000 documents. Let's say in a document there can be 3-4 paragraphs, isn't it?
Yes, sir.
So that will be the document. So there we do not do line by line or anything. Okay, this whole thing will be considered as document. One document, 5 paragraphs put together. Second document, another 2 paragraphs, like that. Not only news article, even in review also sometimes you will find a lengthy review sometimes. Okay, here in tweet maximum 3 lines are there, whereas there will be 30 or 40 lines. In the place of tweet, you will have one complete news article there. Okay.
Okay, sir.
But the process will be same. But the only thing is, there one document will have multiple words. You may find the document term matrix, the length of it may be higher, maybe instead of 3,000, you may have 9,000 unique words or 10,000 unique words, bigger number of words will be there.
Sir, how we will get this text data as input, sir? Do we need to retrieve or client will be given?
So there is no perfect way. This is the only thing that will happen. Okay. Most of the times, whenever we think of the data, it depends on the situation or the source. Sometimes we may have to scrape the websites and get the data by ourselves. Sometimes the client will do this scraping and give it to us in still in a CSV form. Sometimes the text articles will be stored inside a folder. One text document will be created. Okay. For every review, one document will be created. So multiple ways of extracting this data will be there. Okay. Or like sometimes we may have to extract it, or sometimes the client may give us in some form. Okay.
Okay, sir. So can we learn like how to scrape the data here?
Yeah, we can learn that also. Yeah.
Okay, sir.
There is a function in Python that where you give the URL link, it will just simply extract all the text form from that link. Okay. And then put it inside the data frame, whichever column that you asked. That is one way of doing it. If you are extracting the data from Twitter, if you create a developer account, it is possible in Twitter to create a developer account. They will give you access every minute. You can download 25 tweets. Okay, there is some code that they will give us, where we can use that code to push or get the tweets from a particular ID or based on a particular hashtag. Those tweets can be extracted and kept in a file. That is also possible.
Okay, sir.
Sometimes if we are seeing the scanned documents, the converting test would be very challenging. So we get in different language. So is this possible? Can we use on the scanned docs as well?
Scan doc, you're talking about images or text only?
Yeah, images. So suppose if
So images is different. So though that image contains text inside it, okay, but still it's an image file. Okay, it is
Okay.
not a text. So let's say if I ask you give me text, then you will be giving me a tweet, isn't it? Converting into lowercase, it is still text only, isn't it?
Yes.
Let's say if I take this, is this number or image? Though there is number inside it, it is still image only, right or wrong? Yeah. So if you have image number 2 and image 3, 2 plus 3 won't work because these two are images. Similarly, if you have text inside this, it is still image only. Do you agree?
Yes.
So first, what we need to do, extract text from image. We have to use a software for it. Then you will have free text, the strings. Then you do the text aligning on it. Okay. Does it make sense?
Yes, sir.
Have you understood what I'm trying to say?
Yes, sir.
Yeah. So though it is text data, but since it is an image file, extract text from there. Okay. Maybe while we are extracting the text, there can be a lot of errors in it. So we have to use the right software, perfect software, which can read the text. And then this text we can use, then we can apply NLP on top of it.
Okay.
Sir, for like NLP also there might be some softwares, like for example, small institutions, they cannot afford a data scientist or data
Correct.
analyst.
Right. Yeah, please go ahead.
So sir, in that case, like they are buying the softwares.
So if you have a particular application, or if you have a particular problem statement, and if there is already a ready-made solution, okay, which is already giving that, okay, then they can buy that software. Okay. So basically, if there is a product, NLP product, which is doing, it is possible. Okay. Let us suppose a problem statement is read the whole text data, generate a word cloud like this. Okay. Okay. Give the
Yes, sir.
top 10 themes. Okay. We are not expecting a data scientist to do all this lemmatizing, etc., etc., etc. Automatically, my tweets should be taken. That should be my input. Automatically, this should be generated accurately after doing all these steps. Okay, that we discussed in pre-process. If there is a product which does this automatically, then we can use it as well.
Yes. Okay.
What we'll do is we will take a quick break. We'll meet at 11:30 a.m. Then we will get into the analysis of the text data, which is the sentiment analysis. If you have the text data, how do we do the sentiment analysis? Okay. I'll see you right after the break. Welcome back, everyone. Once you're back at your desk, send me a message. Is my voice clear? Is there any background noise or anything? Okay. Is there any class after this immediately for you? Are you going to have any class right after our session? All right. Sentiment analysis is an application of NLP. I think a lot of you already know what is sentiment analysis. Tell me, if someone says sentiment analysis, I'm talking about Twitter data, or I'm talking about text data like reviews data. What does sentiment analysis mean? Sentiment analysis, what does that mean? Let's say given a tweet,
Responsive.
whether it is
It's a
positive or
positive and
negative.
yes,
Positive or
negative.
Let's say
negative.
somebody has written a review. Is it positive or is it negative? Let's say thousands and thousands of reviews are there. Out of them, how many are positive, how many are negative? That is sentiment analysis. Sometimes it is known as opinion mining, sentiment mining, verbatim analysis, or subjectivity detection. As usual, there are two steps in NLP model building. Step one is converting documents text data into numerical format. What is this numerical format called? This numerical format is known as document term matrix. After that, we do the sentiment analysis. We take the same Twitter data that we have used earlier. At the end of it, you have this gist of the text data, or these are the major themes that were talked about, and we have created the document term matrix. On this, we will be using the model, or we will be doing the sentiment analysis. Which tweet is positive, which tweet is negative is what we are going to do. Let us do one thing. Let's go back to the classroom. In the classroom, we have one more session called NLP sentiment analysis. Go to that sentiment analysis material. Sentiment analysis code.ipython notebook file. Sentiment analysis code ipython notebook file. And then you can execute until this point where you have created the final document term matrix. Okay.